Okay, so this is the first one that I have done it. So yeah, this is automotive technology, chapter 1. Let me get this a little bit better. There we go. All right, so this is automotive technology. What I'm going to be talking about is energy, the types of energy conversions. So we got energy, work, force, and centrifugal force, and the things that kind of fall under force, right? Okay, so energy, right? So energy is the ability to do work. So what is work? Work is the amount of force on an object to move a specific distance, right? So this was an object. It's in place, and this goes with Newton's second law, which is the law of inertia. An object at rest tends to stay at rest, and object in motion tends to stay in motion. So work is the amount of force on an object to move a specific distance. So if we wanted to move it this way, we'd have to exert some force right here to make it make the square to make it move. And there's a threshold before you're able to move it, right? And you can calculate force, but going on an energy, energy is not lost or comes out thin dust, it's not created or destroyed, it's only converted. So chemical energy, right, we use that as eating stuff, and we can do work, we are able to ride a bike, do things. Electricity can cause radiant light, right? So here's the 6 different types. So it's kinetic, this plus potential energy, right, equals total energy. So all of these can go pretty much in this category, in this whole thing, right? Keep in mind, because this is potential energy until we're eating it and then converting it into our storage, and then we're able to convert it into kinetic energy. So we're able to take that and do mechanical energy, right? Now electrical energy can turn into light, and that's when electrons are able to move and create a spark or a light. And even radiant energy can be made into chemical energy, right? That's how plants are made. And then you got chemical, like batteries and car batteries, which they can be made into charge our components or make light or electronics and stuff like that. Chemical also can do mechanical, just like this. We are kind of like a car in that sense, like gas, right? Combustion. And also creates a certain level of thermal energy, which would be heat. Electrical can do that. So there's a bunch of conversions, right? And here's all the different types. So continuing on, some examples, right? This is some good examples. So alternator, that uses mechanical energy to go into electrical energy. And this is a starter, which takes electrical energy into mechanical as it spits out and starts the engine. See right there. This one would be, if you think about it, this is chemical energy being compressed with pressure and combust, causing thermal energy. This has multiple conversions, so that's kind of neat. And the exhaust sum that. That's how a piston works. And then for energy, like chemical contents in here, you have lead for the battery. You get negative side, positive side. Negative wants to travel to the positive. So this chemical reactions happening right there. That's neat. Super neat. So now we're on the topic of work. Work is the amount of force on an object to move a specific distance, right? We talked about that back here to move, you know. So the equation for work is equal to force times distance. So the amount of force in that unit, right? That unit is going to be newtons, I believe. So working. Oh, force would be like pounds. How many foot for pounds of energy? Foot pounds. How much pounds per foot? That makes sense. How do they figure this out here? 1 second. Yes, talked about foot pounds. I need to know my units better, so that is something they work on. So for force is a push or pull that can be large or small, and it can happen within contact or from a distance. So the electromagnetic field or gravity is force that's from a distance, right? It's kind of just happening all around us. So with work, it's made a lot fucking easier when there's simple machines involved. So some examples that I provided right here. You get the inclined plane, the pulleys, levers, gears, wheels, and axes. So inclined plane, I've left a little YouTube to watch it. But pretty much if you are just lifting something straight up, and say it's an object, you're lifting it straight up, you're lifting the whole damn thing. Let's say this is like 20 pounds, right? And it's a lot harder. I'm not gonna lie. Lifting it straight up, you gotta lift all the contents. Now, if you slide it up a plane, that decreases tremendously. And it's just that it takes more distance, but as this one, because this one you have to go up, you can just go up a short amount of distance, but this one you go a farther amount of distance. It's like someone on a freaking, wheelchair, right? They're like, oh, I'm in a wheelchair. I need to get up oh, should I just go up the stairs? No, that's freaking hard. Somebody gotta lift you. If you have an incline plane, you can do it. And you know how hard it is to go up an incline plane when it's like freaking like that? You have it like this, they're able to just push right up there. So that's kind of neat. And that mechanism right there is going to be wheels and axes. So we just go right there. Oh, I didn't put it. Well, that's great. But you get the gist. Man, this is first time. It's actually going pretty nice. Work simple machines, right? So pulleys in the car. Pulleys is a little different because it just directs the force differently. This thing slides. So you see up here, there's like 4 different ways. And there's types, right? You could take pulley and you could mount it on something sturdy, and you could direct the force through string to different directions, right? Straight down, all like that, and it'll lift the load. Doesn't change, it doesn't help you at all. And you can then put the pulley on the load, right? On a sturdy spot. That's not gonna help too much because you're pulling on the force. Now here's where it gets different, is that when you have 2 pulleys, this becomes incredibly easier as there is 2 things pulling on this while you're only pulling 1. This, it's a 1-to-1 kind of ratio, because you have the other end. So it makes it a lot harder, but these two. And so this is an out display of it where you can compact it and put multiple ones. And the more you have, the easier it gets, you know? And so this is both going up like that with foursome. And you're only pulling on one. So you can have multiple of these. And the more you have, it's all pulling up little weights and it makes it so much easier. And this is a block and tackle. Now with the car, there's a lot of pulleys, a lot of different pulleys you're working with. And it's just to turn the different pumps, right? And this also kind of goes with gears as a simple machine. And this is all timed, really interesting because you can predict how fast each one is going to go just by how big it is. The bigger ones move slower, and the little ones move really fast. So generator, I think that's the alternator. There should be one that's an alternator on here, but that's going to probably turn really fast. And you have ones for air conditioners. So that's super neat. I thought these pictures were good. So continuing on, we have levers. This is so nice when you get into gears because a gear is pretty much just a series of levers, to be honest. So levers, they have three classes. It's pretty much made up of a fulcrum, and where the load is, and where you're putting the effort. That's supposed to say effort. So FLE. And so how you remember the classes is just remember FLE 1, 2, 3. F class 1 is gonna be fulcrums in the middle, and it's just pretty much saying which one's in the middle. So that's class 1. Class 1 would be like this. You got a seesaw, you got scissors, fulcrum right there, effort right here, load on the other. Fulcrum's in the middle. Class 2, fulcrum or load is in the middle. So it doesn't matter which side, load is going to be in the middle, like these two. Class 3 is effort is in the middle. This is kind of interesting, as in clippers. Fulcrum, load, effort, fulcrum, and load. Kind of neat. So gears. Here's examples for gears. This is called a differential. Kind of neat system. This is from your engine. And this is neat, is that with gears, to make them transition smoother, they have a slanted appearance. So they're able to just cross right in. I like this picture because it tells you some interesting parts about this. This is called a spider, right? So this gear comes in, turns the big guy. In turn, so all right, pretty much what I'm getting at is that when a car takes a corner, right? Car's driving, taking a corner. This is larger circumference than this one. These, to make over here, gotta spin a lot faster. These ones don't. And that's why this whole differential is able to spin a little bit faster. And there's one in the front too, I believe. Yeah, I believe so. But other things that use gears is the transmission. That's the most easiest one. I left a link right here. Tells you all about gears. I get more out of YouTube videos than pictures. But pictures are nice, and I feel like with automotive, it's very important. The most basic one you're gonna get is from a bike. Now, if you're gonna go up a hill, you want to put less effort but get more out, right? And then it gets some topics about torque and stuff like that, right? So you in a small little guy with a big what is it? A big gear is going to turn it more slowly but have a lot more force, right? And you just put in a little, like, same amount of effort. But if you went in this big guy, that'd be so freaking hard, and this thing would be hard to, to take off because you're just putting your whole weight on here. So yeah, having 21 speed is way nice. So now we're on the topic of force. Force is push or pull that can be large or small in the contact or from a distance, right? We talked about that back here. So what they talk about in the book is man, I wish I can say this right. Centripetal force and centrifugal force. So pretty much easiest way is centrifugal is like if you were going to have, if you did track and you're gonna swing this ball, right? You're gonna huck it and fly it, right? You get some massive spin when you spin it, some force when you try to throw it. This is my dude. He's trying to throw it that way. So centrifugal force goes out. Now centripetal, interesting. This one is like with the earth and the moon. You get what I'm saying? Imagine this being earth. It draws in the moon. If it wasn't like that, the moon would just go flying. It would just go, or go straight out. So interesting. Force, will, balance. So with force comes different, like the wheel has a balance, right? This goes on with the wheel and axis. I didn't really explain it very well. I didn't have a thing on it at all. But if this is heavy, every time that goes around it, it's going to put more centrifugal force outward than all the other ones. It needs to be equal. And if it was on, if this was looking a tire head on, it was right here, that's going to cause it to wobble side by side, While this one's going to go up and down shake. They call that tramp. They call this tramp when it goes up and down. They call this shimmy. But to fill up a tire, right? Force can also be, compressed, right? And that's called pressure. And it's over a given area. So force over a given area wanting to escape, right? So torque, this is interesting. I learned about this and this was very cool. Imagine a wrench. It's only 1 foot. It's the same thing. It's like force times leverage, the distance from the pivot point. This is exactly the same as a lever. Exactly. It goes off pounds per feet, right? Important unit. So if I'm able to increase the distance, I'm able to get so much leverage. Same thing as lever. If I'm able to get distance, I'm able to lift that sucker. And I think Archimedes said something where it's like, if you give me a long enough lever and a place to stand, I will move the world. And that's about right. Then we talk about power and horsepower, and that's like the rate or speed at which work is done. And torque is then explained in horsepower. So power, right? They give this sometimes unit as watts. Which Watson, let's see, watts. So it's 1 Newton meter per second, I believe. Yeah, per second. And they consider that a watt. So that's kind of neat. Horsepower is torque times engine speed. So whatever the torque is, which is given as like how many feet per pounds, but there's this one guy who was like, yeah, I want to see how much a horse moves, right? So he does this weird experiment where he's like takes a horse and he sees that an average horse can move 330 pounds, 100 feet in 1 minute. Okay, that's pretty cool. And then he kind of converted it where he's like, well, if you know that distance, then they should be able to, 1 horsepower can move 300 3 33,000 pounds in 1 foot in 1 minute. That's a little ridiculous, but it's it's he determined that. So it's determined, okay? So yeah, no ifs buts. This is end questions, and I'm gonna go after that after I'm done with all this. So yeah. Not the greatest teacher, but I'm gonna kill it at this. I'm gonna discard that. So I hope everyone enjoyed that. I'm gonna post it up. Peace out.